All right, let's take a minute and review the substituted hydrocarbons, and then we will do some practice. So, remember, there are only two with nitrogen, amine and amide. Only difference being that letter right there, N versus D in the name. The key is amide has the nitrogen and the double bonded oxygen on the same carbon, and the amine just has the nitrogen. Now, there could be a double bonded O like way over here someplace, which actually looks like it's just a shocked face, but way over here someplace, there could be a double bonded O, but it has to be on the same carbon to be an amide. Now, there are a whole bunch with oxygen. So I just had an idea. Double bonded O, double bonded O. Double bonded O is in ketone. It's in aldehyde. It's in carboxylic acid. Esters. And amides. So you can have a double bonded O in all of those. So what's the difference? Ketone, the double bonded O is on end carbon. Aldehyde, the double bonded O is not on the end carbon, and it's only a double bonded O. Carboxylic acid has an OH on the same C. Esters have an O on the same C, and amides have an N on the same C. So aldehyde and ketone is only, carboxylic acid, esters, and amine are plus OH or O or N, all on the same C. So let's see if it has an OH. Then it is an alcohol, alcohol, or carboxylic acid. And I'm thinking those are the only two. If I missed something, let me know. So OH, if it's, wow. Looks like Corey wants to get in multiple times. How's that happen? All right, so anyway, only an OH is an alcohol plus double bonded O is carboxylic acid. And that would be up in this list from the other direction. Double bonded O plus OH is a carboxylic acid. N, if it has N, it's an amine or amide. And I think this is a good idea, except for I don't know if squeezing it on the edge of the notes is working all that well. Only an amine, only an N is an amine, an N plus double bonded O is an amide. And then, of course, we've got if it has something has a halogen, then it's a halide. And remember, halogens are things from group 7A. All right, so there's our list. Maybe I can clean that up and make it easier to follow. Maybe I'll clean it up, make it easier to follow, and send it to you. Well, for now, let's practice. So here's a sheet. This sheet is on LMS, except for you can't just click on the, you can't just look at the chemistry file because it's listed as an announcement because it's not a quiz or an assignment. I didn't want to freak somebody out with assignment or quiz. So you can't just look at the chemistry tile, you have to click on it, and then you should be able to see this worksheet if you wish. It's totally optional if you wish to print it out and follow along as we go. All right, now notice up here in the corner, it says right here, it says circle state name. That's how I want you to do these. I want you, and that's cryptic, I know. I just want you to remember circle state name. So circle state name is circle what's different, state what it is, and then name the compound. So in the first one, these aren't numbered, this is just practice. What's not carbon, regular carbon and hydrogen? This is regular carbon and hydrogen. So what's not regular carbon and hydrogen? OH. So we circle it. Now we're going to state it. This is one circle. This is two. We're going to state. OH only. So only an OH is 3 and alcohol. Now, our ultimate goal is to name what kind of substituted hydrocarbon it is. But a lot of people don't get the hang of how to figure out what the name is. So that's why we're going to say circle it and then state what's different and then name what kind of compound it is. And tomorrow or the next day, I'm going to give you one to do on your own. And if you want full credit, you will need to circle, state, and name. All right, moving across, circle what's different. Well, this is all CNH. So this is what's different. So that's the first thing. State what's different. It is a double bonded O on the end, double bonded O on end, and a double bonded O at, and by the way, only a double bonded O. So only a double bonded O on the end is, let's see, aldehyde. Now, if you do this and get them wrong, I can, if you like, you put ketone for this, I could still give you part credit for seeing that you were at least working through it. So the next one, what's different on this? Right there. So we circle it. And then secondly, state, it's a what? O between two C's. Oxygen between two C's. And that's all there is. There's nothing else. So that would make it a ether. And you know where the raise your hand button is if you have any questions about this. The next one, moving to the right, the next one is going to annoy some of you. So don't jump to conclusions too quickly on this one. So what's not the regular CNH? What's different? It's right there. So that's our first thing. Number two, what is it? It's a double bonded O. Now, is it on the end or not on the end? And this is what's going to bug you. This compound actually has 3 quote unquote end carbons. This is an end, E for end. This is an end, and this is an end. Now, every year people look at this and they say, but it's not on the left or right, it's in the middle. But an end carbon is a carbon that's only attached to one other. I mean, if we were, if I could take this whole picture, which I can, but not quickly, and I'm not going to waste time with it. If I could quickly and easily take this whole picture and rotate it 90 degrees clockwise, then this C would be over here. Well, anyway, it does count for an end because the carbon is only attached to one other carbon. It's not attached to 2 or more. So this is a double bonded O on the end, and it's only that, there's nothing else. So that would make this another, just like up here, aldehyde. And that one, some of you are going to take a while to get used to it. I understand that. Moving to the next row, what's not C or H? It's this right here. And so that's our first thing. Number 2, what is that? Well, it's chlorine, which is a halogen. And having a halogen makes it a halide. If you can't remember what the halogens are, if there's something that doesn't make sense, it's not O, it's not N, it's not OH, then have a periodic table handy on paper or in a book or on your computer so that you can see if it's in group 7A, or just memorize the ones in 7A. But memorizing is so much bother, right? Right here, oh look, we've got an O between 2 C's and a double bonded O on the same carbon. So there's number 1. So state, double bonded O and O between 2 C's, same carbon. And let's see. If we looked at this, if that helps you at all, double bonded O plus an O between 2 C's makes it an ester. So number 3, this would be an ester. Two more to go. The last one will bug you again, but before that, so right here on the lower left corner, what's different? The N. And what is that? That is nitrogen, or N, and it's only N, no double bonded O, which makes it an amine. Whoops. Start writing the N to M too quickly. Now, the last one will bug you. What's not C and H, regular C and H? Well, we've got a double bonded O there, and we've got an O between two C's there, but they're on two different carbons. So we've got double bonded O and O between two C's. Now that starts to sound just like the one above it, except for when we get to here, it's not the same carbon, it's different carbons. So it is not an ester. Now, what in the world is it? We didn't talk about one like that. Well, here's the deal. If they're on different C's, then we have O between two carbons is an ether. And a double bonded O by itself on a carbon is, oh, and it's not on the end, so that would be an ether and a ketone. It would be two different substances. Can you do that? Absolutely. It's very common in organic compounds to have multiple functional groups or substitutions at different places, especially when you get into some of the more advanced compounds in biochemistry or organic chemistry. So that's just practice. Doesn't count for anything except practice. Tomorrow, we'll probably do some more practice, and I'll either tomorrow or the next day give you, probably tomorrow, some for a grade. All right, back to the notes. So, biological compounds, biological molecules, 4 categories: carbohydrates, lipids, proteins, and fats. Just an awful lot of confusion if you just look at it and don't spend time dealing with it. They have subunits and subgroups. Talked about this yesterday. The subunit is what they're made of, and the subgroups are the different kinds of them. These are complicated compounds. I mean, they reduce to simple parts maybe, but these are complicated compounds. I mean, all of life runs on these things, so they have to be complicated. So now we're going to start into them, going to try and make sense of them. Obviously, we're not going to get it all at once. So we will start with carbohydrates. Okay, carbohydrate. This is not something that you need to learn, but in case you're interested. Carbo refers to carbon, and hydrate refers to water. Like, if you are thirsty, you are dehydrated. So this literally means carbon and water, and it's because the general formula of all hydrocarbons is CH2O. So glucose is C6H12O6. And if you reduce that, divide through the subscripts by 6, you get CH2O in its empirical formula, its reduced formula. If you took starch, starch would be starch would be C6H12O6 to about the 200. So that would make it what? 1200 and 2400 and 1200 if we were to give everything its subscript. So you divide through by 1200 and you get CH2O. So that's why they're called carbon and carbohydrate, because they've got carbon and what looks like water in the formula. But that doesn't mean that they've got water in them. They just have hydrogen and oxygen in the same proportions as it is in water. 2 hydrogens for every 1 oxygen. But if that confuses you, the good news is you don't have to know it. And for those of you who like this kind of stuff, it's interesting maybe. All right, so whoa, what in the world? Just took off on me. So the subunit is glucose. Now, look at this. Look at this. Another thing that people get confused with. The subunit is glucose. Carbohydrates are made of long chains of glucose. Remember, I just said, this C6H12O6 to maybe the 200 of those hooked in a chain for starch. 200 of them hooked a different way could make cellulose, which you remember is what's in the cell wall of plants. Or 200 of them hooked together in a different way could make chitin, which is in the cell wall of fungi. So long chains of glucose are what make up carbohydrates, except this is specifically for the complex carbohydrates. Monosaccharides generally are the subunits for the disaccharides. Now, monosaccharide and disaccharide are terms that you're probably not familiar with. There's going to be a lot of terms in here that may be foreign to you. That's the nature of biological chemistry, biochem. It's just the way it is. That's why there's so much memory involved with these chemistries, at least at first, while you're getting all of the names and all of the ground rules sorted out. So notice, and I understand that there's a lot and it keeps crisscrossing back and forth. It's the nature of this kind of chemistry. There are two kinds of simple sugars. There is the monosaccharides. Mono is one or single, and there are the disaccharides. Di is two or double. So a single sugar molecule is a monosaccharide. If I hook two single sugar molecules together, then I get a double sugar, but it's still one molecule. That's why it gets confusing, because the two molecules have been combined. So one is a monosaccharide. For example, you've heard of fructose. Fructose is the sugar found in fruits. It's also found in corn. And they can make, you've heard of this, I suppose, high fructose corn syrup from it. Fructose, though, is a naturally occurring sugar found in fruit. It's what makes peaches and apples and any other fruit sweet. It's what makes oranges sweet, except for then it has citric acid that makes it tart too. It's actually in grapefruit. Grapefruit are sweet, except there's so much citric acid that the tartness, the sharpness is overwhelming the sweetness. Kind of like me. No, there's no sugar in me. I don't know what I'm talking about here. Glucose is blood sugar. And we've heard of glucose, if for nothing else, because we've talked about it in biology and chemistry several times. Okay, so fructose and glucose are example of single sugars. The super simplified diagram, and this is missing some parts, but the super simplified diagram is that for a single sugar. Super simplified, because there were 6 C's. There's only 5 C's represented here. Where's the 6th C? It was actually up here, but we don't show it. And all of these O's, we're only showing one O. So this is super simplified. You don't have to understand anything except for that it's super simplified. So if we drew the superest simplifiedest diagram of a monosaccharide, depending on which monosaccharide we drew, it might look like that. And it's possible to do a neater job. A disaccharide, if we took 2 of these and put them together, we would have a disaccharide, which is 1 single sugar, 1 monosaccharide, and another single sugar, another monosaccharide, and then they're hooked together, combined. So that is a 1 sugar molecule, monosaccharide. This is 2. Okay, so 1 sugar molecule. This is 2 sugar molecules, so it is a disaccharide. But they are both thought of as simple sugars. Why are they simple? Because the polysaccharides, the complex carbohydrates, have hundreds of these hooked together in their chains, not 1, not 2. So monosaccharides, single sugars, 1 sugar molecule, disaccharides, double sugars, 1, 2 single molecules, polysaccharides, poly is many, complex carbohydrates, hundreds, and I'm not going to try to draw a picture of hundreds of those in a row for reasons that I think should be pretty obvious to you. So those are the subgroups. And back up to here, let me emphasize this, and then I'll let you go. For the complex carbohydrates, the subunit is glucose, which is a monosaccharide, but it's a specific monosaccharide. The subgroups for disaccharides are different combinations of monosaccharides. And monosaccharides basically are the subunit, so they don't have a subunit. So, yep, I know it kind of is a little bit confusing. After you think about it enough times, the confusion, your brain sorts it out, and your brain knows what's coming, that monosaccharides and disaccharides are two monosaccharides. But it does take thinking about a while to get it all sorted out. So I'm going to let you go. Make sure you get the quiz done. Don't forget that Mr. Pahalski has a online chapel in, I think, half an hour, and we'll see you later.